Okay, for our next bit of this video, what we're going to have a look at is how to name and write out the chemical formulas of ionic compounds. We'll look at some common ones that really come up a lot, but most importantly, I have to teach you how to do this process yourself, because you can't just make up the chemical formula of something. Like, the chemical formula is what it is, but there are rules for working out what the chemical formulas are. But to be able to do that, you have to be able to know what the ions are first. That's why we spent those couple of videos just doing the ions first. Without you understanding how the ions form and what the compound ions are, a lot of this video will be difficult. So maybe if you're finding something difficult, you don't understand what I'm explaining, stop the video and go back and re-watch the other two videos first to get yourself to the point where you can work out what it is that I'm doing. Okay, so say I need to work out what the formula of sodium chloride is. Now, this is a nice, easy example. Whenever we are asked what the chemical formula of something is, you have to look at the ion and work out what it is that these ions have come from. So sodium, if you remember, makes an Na plus ion. And the chloride ion is a Cl minus ion. Now you'll notice that there is one plus and one minus. Plus and minus cancel each other out. So therefore, the formula of the ionic compound is going to be NaCl. Now, please notice that I haven't drawn the plus or the minus on the Na and the Cl, because when these two things react, the charges are negated. They disappear, don't they? Because you've got a positive and a negative. So when they join together and form a compound, the positive and negative cancel out. They disappear. They're not there anymore. All right. Let's look at a little bit more of a complicated one. Let's go for magnesium oxide. Right, magnesium oxide. So what's the charge of the magnesium ion? It's 2 plus, Mg2 plus. And what's the charge of the oxide ion? It's 2 minus. Now you'll see we've got 2 pluses here and 2 minuses here. 2 plus and 2 minus cancel each other out. So therefore, the formula of this one is going to be MgO, because there's a 2 plus and a 2 minus, and if those react together, then the charge will disappear. Okay, let's have a little bit more of a complicated one now, much more complicated in fact. Let's have a look at magnesium fluoride instead. Magnesium fluoride. Now magnesium is in group 2. We saw it up here in the previous question, so we can just write there that that's Mg2 plus. But fluoride is in group 7. And this means that it can only take a -1 charge. So we've got 2 plus and we've got minus. Well, when they cancel out, they don't equal 0. They don't cancel each other out. These don't cancel out. But we have to make sure that it does, because every positive charge has to be accounted for a negative charge. There's going to overall be a neutral molecule. Well, how can I do that if this is a minus and this is a 2 plus? It doesn't seem possible, does it? Well, the solution to that is that there's actually twice as many fluorines as there are magnesium atoms. Look here, I've got 2 fluoride ions. So I just need to write down that we've got 2 separate negatively charged ions in there and 1 single 2+ charged magnesium atom. So the formula would be Mg F2. Now this one does balance out now. The 2 here represents that there are 2 fluoride ions, and you can see them here, there, and there. So we've got 2 fluoride ions, that's why I've written a 2 here, and only 1 magnesium ion, that's why I've written this MgF2 here. Alright, let's have a go at a different one now. Let's work out what potassium sulfide would be. Potassium sulfide. Pause the video now, see if you can go and find it using your periodic table, and then we'll come back to it. Okay, hopefully you've got your answer ready. So, potassium is a 1+ ion because it's in group 1, and sulfur is in group 6. So that will form an S2- ion. Now, if these two things react together, then obviously what we're going to need is we're going to need to have 2 K potassium ions here, because now I've got 2 pluses there and 1 2- there. I've got 2 K+ ions and I've got 1 S2- ion. So what's the formula? The formula is going to be K2S. Okay, let's try another one now. Can you try and work out for me aluminium bromide? Okay, pause your video now and try and work it out for yourself. Alright, for aluminium bromide, let's have a look at the ions. Now aluminium is in group 3, so aluminium is a 3+ ion, and bromine is in group 7, which means that it's going to form a Br1- ion. Now there are 3 positive charges but only 1 minus charge here. So I'm going to need 3 lots of bromine ions to make up the 3 positive charges so that they all cancel out. That means that my chemical formula is going to be AlBr3 because there are 3 bromide ions needed to balance out the 1 Al3+ ion. Okay. Right, let's add some more difficult ones now, some that introduce those compound ions that we've been looking at. Let's have a look at iron 3 hydroxide. Right, iron 3 hydroxide. If you remember, if you've got a number in a bracket like this on the iron 3 in Roman numerals, that is the charge of the ion. So we know that this represents an Fe3+ ion. Hydroxide as an ion, if you remember, it's a compound ion containing hydrogen and oxygen. You can tell from the name, hydroxide. So this was the OH- ion. Now we've got a 3+ and a 1-. So just like we saw previously, we're going to need 3 OH- ions there. Now you might think what's sensible is to write FeOH3, just like we did before. But when I'm reading this, it actually says 1 Fe, 1 oxygen, and 3 hydrogens. But when I look over here, you can see that I've got one Fe, yes, I've got 3 hydrogens, but I've also got 3 oxygens as well. So this can't be correct. This is not the correct answer here. Now we could do this a really long-winded way. We could say, well, I've got Fe, I've got 3 O's, O3, and I've got 3 H's. But that's also quite silly, because you don't really get the point of this hydroxide ion being together. It's stuck together as an ion, if we remember. So instead we can use brackets, just kind of the same way that we do in maths. We've got 3 OHs here, so we can say we've got 1 Fe, and we've got 3 OHs. We draw it in brackets, the OH is surrounded in brackets, and you state that you've got 3 of those OH minus ions, because I've got 3 hydroxide ions, and I have 1 Fe3 plus ion. Okay, see if you can have a go with the next following compound ion. The compound ion I'd like you to try and have a go at drawing is ammonium carbonate. Ammonium carbonate. Let's see if you can give this one a go. Alright, you won't have found ammonium on the periodic table. It's a compound ion made of NH4+. And you wouldn't have found carbonate on the periodic table either. That is the CO3 2- compound ions. These are both compound ions. Right, let's look at the charges. We're going from 2 here to only 1+ over here. So I need an extra ammonium ion in my substance. Right, I've got 2 ammonium ions. So I can put it in brackets, NH4, close brackets, and then we can put in the carbonate ion, CO3. This is the correct chemical formula. Oh, sorry, I forgot to put in the 2 there to represent that there's 2 ammonium ions. So now this is the correct formula, because I've got 2 ammonium ions and only 1 carbonate ion. Last example. Have a go at doing aluminium sulfate. Aluminium sulfate. This one might be quite tricky, so please have a go and try and work it out before you press pause and have a go. Okay, let's have a look at the charges that we have here. Aluminium is in group 3, and so we know that forms a 3+ ion. And the sulfate was one of our compound ions and forms SO4 2-, like this. So how is this going to form a compound? This doesn't kind of go in regularly. I can't just add one or the other. See, let's start here. I've got a 2- charge. Well, that's less than 3+. So let's add another sulfate ion. Right, I'm just going to do a running total of the overall charge right now. So I've got 3+, and I've got 4 minuses in total, because I've got a 2- and a 2-. So overall, this equals 1-. I've got to get this to equal 0. It has to cancel out. So this is a bit rubbish. We've got too many minuses. I'm going to have to add an extra positive. All right, I've added an extra positive 1, but obviously, our aluminium, I have to add 3- at a time. So now, what's the overall charge? Well, this becomes 2+, because I've got 6 pluses here, but only 4 minuses. So I've got an overall 2+ charge there. Right, I've got too many pluses, so it's going to have to add another minus, SO4 2-. Let's recalculate what's going on there. I've got 6 pluses, 6 minuses, as this equals 0. That's perfect. It's cancelled out, And so this will be my formula. I've got to simplify this down so we can fit it onto a line. I've got 2 aluminium ions here, so that's going to be Al2. And I've got 3 sulfate ions. Now, because these are compound ions, we have to use brackets. So I'm going to open the brackets. SO4, close brackets. And there are 3 sulfate ions, so you can write a little 3 down here. And this is our formula for aluminium sulfate. This is a skill. You have to practice it. You have to keep trying and trying and trying. You won't get it the first time. But the more you do, the more you try, the better it will go. Have a go at doing the worksheet of all of these ions, all of these ionic compounds that I've given you. And please give me those in the assignment. Right. Good luck, guys. And I'll see you next week for another video.